Listen. Okay. 7-2, we're going to start doing some math today for our hypothesis testing. This lesson goes along with section 6-1. So remember we did two confidence interval sections. The first confidence interval, section 6-1, was where we knew the standard deviation of the population, and that's where we used our Z's. This lesson goes along with that. So we're going to be hypothesis testing for the mean. So we're not going to be hypothesis testing for standard deviation or variance or proportions. We've mentioned those in passing. And in all of the problems that we're going to do in this section, we are going to know the population standard deviation. And because we know that, we're going to be able to use our Z value. So today we're just going to talk about some basic pieces that you're going to need in the hypothesis testing, some math behind it. So we saw this in the last section, this little chart here about the decision rule. And I mentioned the P and alpha. So alpha, remember, is a level of significance that's predetermined. So it's going to be like 0.10 for 10%, or 0.05 for 5%, or 0.01 for 1%. P is going to be an area under the curve, and it's either going to be to the left or to the right or on either side, depending on if we have a left tail, a right tail, or a two-tail test that we talked about before. If P is less than or equal to alpha, we're going to reject the null hypothesis. That's going to help us make our decision. And if P is greater than alpha, then we are not going to reject the null hypothesis or fail to reject. So in this problem at the bottom, they're telling us what the p-value is. So the area under the curve is 0.0237, a value that you could find on your Z chart if you have a Z-score. We're going to use that to determine whether or not you would reject the null hypothesis at a given level of significance. So for part A, my level of significance is 0.01. So we want to compare P to alpha. In this problem, P is 0.0237 and alpha is 0.01. Is my P less than, greater than, equal to? Those two numbers? It's greater than. So if P is greater than alpha, we do not reject. And we talked about yesterday, rejecting in hypothesis testing is a good thing. If you reject, that tells us you have enough evidence to make a decision. So when we don't reject, it's not exactly what we're going for. All right, so what if the level of significance is 0.05? So again, we're going to compare that p-value to my level of significance. Is it greater than, less than, equal to? Right, so my p is less than in this case. So as long as P is less than, we would reject the null hypothesis, which would mean there is enough evidence to either reject or support the claim that's being made. And then the last one, these are getting bigger each time, 0.1, also less than, so we would make a decision to reject. Okay? Questions there? Great. All right, so on the next slide, these are for you to try, and we'll put answers up on the board. So in each section of this table, you're going to compare the p-value on the left, the level of significance on the top, and then in the box say if you're going to reject or not reject. Okay, so I'll give you a few minutes to put answers on the board. Go. All right, do we have any questions on this? No? Good? Okay, so we've already talked about how you know if it's going to be a left tail, right tail, or two-tailed test. Remember that came from the alternative hypothesis. So now what we're going to do is start figuring out where we're going to get that p-value from. Okay, so for a left-tailed test, P is just the area in the left tail. So you guys are going to be able to find that on your Z chart. For a right tail test, it's the area in the right tail. So if you guys remember, we wanted an area to the right when we did our Z-scores before, we did 1 minus what we found on our chart, the complement. And then for a two-tail test, we're going to do, my probability is going to be 2 times the area to the left, pretty much. We're going to find the area to the left and then multiply it by 2. Okay, so we're going to practice this. You need your standard tables, your Z-score tables. If you guys have those handy. I'll grab mine too here. All right, so for a left-tailed test, we have a z-score of negative 1.55. So that is your z-score. So that's what's on the left and on the top of your chart. So let's see, negative 1.55. You're going to get a p-value of 0.0606. Okay, and that's it. You have no extra calculations to do. All right, compare that to the alpha. The alpha is 0.05. Would we reject or not reject? P is greater than alpha here. So you do not reject. Okay. Right tail test. We have a z-score of 1.23. All right, so to find my p-value, we're going to do 1 minus whatever we find on the chart, the complement of this. All right, so 1.23, the cumulative area is 0.8907. That's a terrible 9. Come on. 8907. All right, and then we type that in our calculator. So what's that going to give me? 0.0193, is that right? Oh, 0.1093. Okay. Comparing it to my level of significance, 0.1. Do we reject or not reject? Reject. We do not. Because again, the p is greater than alpha here. So we do not reject. Okay. All right, and then finally a two-tailed test. So when you have a two-tailed test, your z-score will be one of two things. It'll be the z-score on the left or it'll be the z-score on the right. Now here, they're giving us a positive z-score, which is the one on the right, 1.95. If I use the one on the right, I have to use the complement of it then when I find the area. So what I would suggest is use the opposite, and that's going to be the one on the left, and you don't have any extra calculations to do with it. Okay, so negative 1.95. Let me find that guy. That's going to be the area in the left tail, which is 0.0256. And when it's a two-tail test, we just double it. Okay, so we find the area in the left tail, which we need the negative value for that, and we double it. So 0.0256 times 2 gives me a p-value of 0.0512. My level of significance here is a 0.08. Do we reject or not reject? Reject. We would reject. Here the p is smaller than alpha. Okay. All right, there are 2 on the next page for you to try, and then we just got 1 more slide after this, and we're done. Try these 2. Tells you what kind of test it is. Find the p-value, compare it to alpha, decide if you're going to reject the null or not. All right, when you're ready, answers. The top one, you should have a p-value of 0.0129. Nothing special from the chart on that one. It's greater than your alpha, so we do not reject. For the one at the bottom, it's easier to use the critical value from the left of the chart instead of the right. So if you look up negative 2.14, you get 0.0162. Double it, 0.0324 is less than alpha, so we reject the null. Okay? Questions? All right, last problem is just how you can get a p-value from your graphing calculator. Let me show you this real quick. If you want to grab your graphing calculator, you can follow along if you want. This slide kind of just walks you through the procedure. So in order to do a z-test, a hypothesis test on your calculator, you do need some data, which you would have for any given problem. So here, the null hypothesis that we're testing about is 6.2. So 6.2 minutes, and it might be greater than or less than or equal to. I'm just throwing minutes out there as a label, but that's what we're testing on. We have a standard deviation of the population. You would have to know that. You have a sample mean, you have an n value, and then we're going to tell the calculator, this line here, is if it's a left tail, right tail, or a two-tail test. Less than is a left tail test, greater than is a right tail test, and then when it's not equal to, that's when we have the two-tailed test, okay? So in your graphing calculator, to find this, you're going to hit Stat and go over to Tests, and then we want a z-test. If you know the population standard deviation, it's a z. And then when we don't know the population standard deviation, it's going to be a t, but it's going to look really similar in the next section we do those. So we're going to hit option number 1. You're going to hit stats this time. Data is if you have the raw data or the raw sample data. We don't have that. We're just going to use the statistics we know. And then it gives you all these options. So the null is 6.2. The standard deviation, it's a little hard to see up here, is a 0.47. There's a decimal there, 0.47. X bar is 6.07. N is 53. And then it's a two-tailed test. And the color is unimportant. Okay. Then you can hit calculate once you have all of those options. And here's what the calculator tells you. Let me drag it over here so I can zoom in on it a little bit. There we go. So it tells you the z-score associated with these values, which we'll eventually calculate that on our own. But then what's important is the p-value. That's what we want to focus on. If we don't have it on our chart, we can find it on here. So you want to then compare the p-value to a level of significance. So let's say my level of significance was 0.05. 0.04 is smaller than that, so I would choose to reject. Okay, so the calculator doesn't tell you to reject or not because you don't give it the level of significance, but you can use that p-value to determine your answer at the end, your decision. Okay, that's it that we're going to do today. 7-2 day 1, done. All right, so your 7-1 Math XLs are due tonight. As a reminder, if you've not finished those ones up, you can do 7-2 is the same thing in Math XL. It's divided into little mini sections. So 7-2 day 1, you guys can be working on. All the 7-2 Math XLs are due on next Wednesday night. Would be your next deadline. Okay, but again, you should probably be able to get them done as we're doing them. All right, I'll do cell phone lotto. Last bit of the period is yours.